as me, and he's about 3.5 years younger.
Oh, so what are you doing personally?
Well, most of the time I'm in the lab and trying to run a bunch of companies to make these drugs a reality. But daily, I try to keep a healthy weight. I do intermittent fasting, which is pretty easy because I'm so busy I forget to eat.
How many hours do you give yourself every night?
Well, I suffer from late night snacking, but I try to skip breakfast and even skip lunch if I'm busy. So I'm a night eater. But that seemed to be good because a study came out about a couple of weeks ago, at least in mice, that it's not what you eat, it's when you eat that's most important for longevity.
Really?
Yeah.
And when being when? Like what's best?
It doesn't actually matter if you eat a lot in the morning or a lot at night. I like nighttime eating. But you need a period during the day, at least if you're a mouse, probably if you're a human, where you're hungry. And that puts your body in a defensive mode. And these are the things that we've been studying in my lab for the last 20 years. What are the processes that diet and exercise do for us that keep us healthy? And why does calorie restriction and intermittent fasting make animals live so much longer? And we think we've figured out a large part of how that works, and now we're mimicking that with molecules.
Is the idea that you can mimic it with molecules and it'll be as effective as intermittent fasting?
I think the molecules will be better. And not only that, when we add them on to a healthy diet and exercise in the animals, they do even better. It's like a supercharged mouse.
Now, when you add them on to the mice, do you also add them on with intermittent fasting? And is there an additional benefit?
We do. One of the first molecules infamous molecules that we are known for is resveratrol from red wine. That molecule, discovered it in my 30s, or at least linked it to aging. What we showed was that if you give it to a fat mouse, they're as healthy as a thin mouse. They live just as long. They didn't get heart disease and all of the other bad stuff. Then what we did was interesting. We gave it to the mice either every day in their food or let them skip a meal every day so that they were fed every other day. And that combination of resveratrol plus every other day feeding, we had the longest lifespan we'd ever seen. And it was additive. Same with exercise. If we give our latest molecule called NMN to a mouse and we exercise it, it'll run even further than it could with either of those alone. So it's not an excuse to sit around and just eat chips and watch TV. It augments a healthy lifestyle, gets you further than what you could get naturally.
So are you seeing a benefit in addition? So is the idea to compound all those things together? Exactly.
Right. So you asked about myself. So I eat healthy. I try to skip meals. I also take supplements. And in fact, most of my colleagues are in the field of aging, or anti-aging as people call it. So I take NMN every morning.
What is NMN?
Good question. So let me take a quick step back.
Sure.
So about 20 years ago, Lenny Guarente and a team of us at MIT discovered a set of genes that controls aging in yeast cells, just brewer's yeast, what you find in beer and bread. And those genes are called sirtuins, and there are 7 of them in our bodies, 5 in yeast. And what they do is they protect all organisms on the planet, plants, bacteria, humans, from deterioration and disease. They're like the Pentagon. They sense when we're hungry, sense when we're exercising, and they send out the troops to defend us. So when you put more of these genes into a yeast cell or a mouse, they'll live longer, between 5 to 20% longer. And so we think that these genes are responsible for the effects of dieting and exercise, which is great. What that means is we can now mimic that with molecules. So NMN is one of those molecules, so is resveratrol. You can think of resveratrol as the accelerator pedal for the sirtuin genes, and the NMN is the fuel. And without fuel, resveratrol won't work, so NMN is the gas in the car.
I've heard of resveratrol, but is NMN a new molecule? Is this commercially available?
Some people have started selling it on the internet.
The fucking internet.
It's related to NR, which is sold by a bunch of companies.
NR?
Yeah, nicotinamide riboside is a supplement that raises the levels of a molecule called NAD.
I feel like I should make a shopping list.
So get a pen. So while you're writing that down, Joe, so the sirtuins, okay, get this. So sirtuins need NAD to work. Without them, they don't work. In fact, if you don't have NAD in your body, you'd be dead in about 30 seconds. It's a really important molecule. But as we get older, we lose NAD. So by the time you're 50, like I almost am, you have about half the levels of what you had when you were 20. So that's not good. And these sirtuins, they don't protect the body without high levels of NAD. So what NMN does, and this other molecule called NR, which both you can get on the internet, they boost the body's levels of NAD back up to youthful levels again. And if we give them to mice, these molecules to mice or even to worms or yeast, they live longer and they're super healthy.
Now, what level, like how many milligrams are you taking of these things?
NMN is something I get from myself. I'm not selling anything. So I take a gram of NMN in the morning. Based on clinical trials, it's been shown that will raise NAD.
With or without food?
I take a little bit of yogurt that I make myself at home just to settle me. I've been doing this for a while, and I only start doing stuff when I see it work in animals first. So take the yogurt, mix in some resveratrol. Resveratrol is great, but it's really insoluble. It's like brick dust. So in the yogurt, it'll dissolve. Take another half a gram of resveratrol.
And how much? Half a gram?
Yeah. It's a powder. I have a few kilos left over from clinical trials in my basement. That's going to last me a few decades. And then I also take at night some Metformin, which is probably the most radical thing that I take, which is a prescribable drug for diabetes.
Metformin?
M-E-T.
And prescribable drug. But you don't have diabetes.
I do not.
But you take it for
preventing cancer, heart disease, Alzheimer's, and aging.
Can you spell it? M-E-T?
F-O-R-M-I-N. And so out of studies of 10,000 people and more, it's been shown that people who take metformin, even if they have diabetes, are protected against other diseases of aging, even frailty. And so most scientists, if you ask them in my field, will say, metformin is likely to extend your lifespan. It's just that the FDA doesn't let you have it for aging, because aging isn't a disease yet.
So do you have to get diabetes to get it, or do you have to get a sneaky doctor?
Well, I wouldn't call it a sneaky doctor, but the doctor typically has to be convinced because they don't keep up with the literature. And
right.
it's off-label.
Okay.
Right.
And how much do you take of that?
I take a gram of that as well, which is about a low dose. Some diabetics take 2 grams, so it's not crazy amounts.
Is there any side effects?
Well, the good news is that it's extremely rare that you get sick from any of these molecules. In millions of patients around the world, nobody's getting sick. The worst you'll have, as far as I can tell, is a stomach upset. And I get that, which is actually helpful. If I'm hungry, I lose my appetite. But I think the downside is extremely low, and the upside is anything's better than what's coming.
And what is the mechanism that metformin is operating under?
Okay. So this is the great thing, is that over the last 20 years, we scientists have figured out that there are universal regulators of aging, from yeast to worms to mice and in humans. And there are 3 main pathways that we figured out respond to what we eat and how we exercise. And one of them is called AMPK, and this is a target of metformin. And so when I take metformin, I'm activating my AMPK, which will send out the troops. The Sirtuins I've mentioned, that's the second of the pathways. And so I take NMN and resveratrol for that. And then the third one is called MTOR, which is a pathway in the body that responds to how many amino acids, how much meat you're eating. And it will also protect the body if you tweak it just the right way. And there's only, besides eating low amounts of protein, the only way to affect that pathway is with a drug called rapamycin, which is a little dangerous to try and is used for immunosuppressants. So it's not something that I would recommend, and I don't take it.
Wow. So this is your daily routine, along with what kind of diet do you follow?
Well, I try to not eat too much. It's pretty easy to overeat, so I try to skip 1 or 2 meals a day. I avoid sugars and carbs. I try to run once a week. I do workouts on the weekend. Like you, I love saunas. I like to put my body in some temperature stress. So I go heat, and then I jump in a cold bath, back and forth. That works well for yeast. We can do that in the lab, and they live 30% longer. So there's all that.
Do you ever
generally I eat normally.
Do you ever try going from sauna to cryotherapy?
No, I haven't tried actual cryotherapy.
Oh, you haven't done it at all?
No.
You want to do it today?
Sure. Have you got one?
Yeah. We'll take you.
Cool.
Take you down the street. There's a great one because it's there's different kinds, and some of them are from the neck down, where they're using liquid nitrogen. The other ones, they actually freeze the air. So when they're using the nitrogen to freeze the air, and they're pumping in air that's 240 degrees below zero, and you're going to do about 2 minutes. I do 3 because I do it all the time, but it's awesome. I do 3 and then I take 10 minutes off and then I go back in for another 3.
Yeah, it makes sense. And what you're doing to your body when you do that, we think, is to activate these longevity pathways like the sirtuins.
Yeah.
And that's really the trick, is to activate your body's defenses against aging. The old theories about aging, you got to throw them out. Most people at parties will tell you, antioxidants, free radicals, DNA damage, or mutations. That is all, for the most part, incorrect.
That antioxidants cause DNA damage?
No, that's true.
That it repairs DNA damage.
Well, antioxidants have been a rather big failure in the aging field.
But resveratrol is an antioxidant, correct?
It's a mild antioxidant, but it doesn't work by being an antioxidant.
Oh, what does it work? What is the pathway?
It steps on the accelerator pedal of these sirtuin enzymes.
Oh, okay.
And so it's directly controlling the body's defenses against aging.
So as we discussed it, or as people discussed it as an antioxidant, it was just a mild form of antioxidant, but it did so much more.
Right. And we know this because if you create a yeast cell or a worm or a mouse, and then you knock out the gene for the sirtuin, now the resveratrol doesn't help the animal anymore.
That's interesting, because when people talk about wine, that's the one thing they say, the resveratrol is an antioxidant. It's really good for you.
Yeah, this is one of those urban myths that never goes away and still fuels $1 billion industry. But what we're finding is that the molecules in plants, like resveratrol, first of all, that we think they're produced by plants because the plants are benefiting from the stress. We call it hormesis. A little bit of stress is good for you. What doesn't kill you makes you stronger, kind of thing. And hormesis was discovered about 60, 70 years ago when people were spraying herbicides on plants, and a little bit of herbicide actually made them stronger. And we think that these molecules in plants are similar. They make the plant stronger during times of stress. So if you stress a grape that's for wine making, you'll get great wine, but you'll also get a lot of resveratrol. And so when we ingest that resveratrol from the plants, we get the same health benefits because the plants are activating their sirtuin pathways, and we have the sirtuins, and they activate us as well.
Ah, interesting. So low carb, low sugar, any specific type of protein? Do you limit your amount of protein?
Yeah, I enjoy eating mammals just as much as anybody, but I try to avoid them for two main reasons. One is that there's this TMAO molecule that seems to cause heart disease.
TMAO.
Yeah.
Yeah. And how is it linked to heart disease? Is these epidemiology studies?
I forget, but I do recall that the study was able to give the TMAO to animals and they developed heart disease. So it's somehow causing it. I forget exactly how. It might be damaging the genome. That's my recollection.
With omnivores or predators?
I think red meat is the culprit.
Right. So are they giving this to rats, or are they giving this to...
It was a mouse study again. So, mice might be different from humans, of course.
Yeah.
But the other problem with meat in general from animals is that there's a lot of amino acids in there, and it's easy to eat a lot of meat. And so if you have high levels of amino acids, it will activate this mTOR pathway, one of those 3 longevity pathways. And you don't want that.
You don't want that.
You don't want that because mTOR has evolved to sense times of adversity and stress and hunger.
So why do people see a performance benefit when they consume branched-chain amino acids?
Really good question. So in the short run, just like taking testosterone, it will give you performance benefits. But we think in the long run, it'll actually come back to bite you.
So how will branched-chain amino acids come back to bite you?
So branched-chain amino acids will activate this mTOR pathway. And when we do that in animals, we reduce their lifespan. So it's the opposite. You want to keep those levels low.
That's interesting. That seems, for a dummy like me, it seems counterintuitive because what's making you perform better currently, you would think, especially something like amino acids, a natural part of the human body, you would think that would be beneficial. You're adding to your body something that it needs. Yeah,
you would. But what you should consider is that it's a trade-off. There's a theory that's probably correct. It's some Tom Kirkwood's theory called the disposable soma. And our bodies want to do one of two things. We either want to grow really fast and reproduce fast, build up a lot of muscle, cells divide. That's great in the short run. You'll be fertile, you can run, but actually that's at the expense of hunkering down and building a long-lasting body. And it's a trade-off over time. And so animals that grow fast and reproduce fast, like a mouse, will only have a short lifespan, whereas a whale that grows slowly and reproduces slowly will live a long time.
Interesting. So the idea is you're limiting your calories, you're limiting your carbohydrates, you're limiting your protein, you're limiting your amino acids, but you're ramping up on all these beneficial molecules.
Right. These pathways that have evolved since the beginning of life to make us live longer during adversity so we can thrive when times come back that are good.
Do you take into consideration quality of life versus length of life? Like, is there a sweet spot?
Yeah, it's hard to ask the mice how they feel, but we do test them, and we do frailty studies, and we can see that they've got better memory and they can run further on a treadmill. They're stronger, those kind of things. They see better. And, we think that probably means they're happier as well.